Welcome to another reduction of order example. So let's consider the equation x plus 1 times y double prime minus y prime plus negative 4x minus 2 times y is equal to x plus 1 squared times e to the negative 3x, which has homogeneous solution y1 equals e to the 2x. Our job is to find the general solution. So just a quick note. This equation does not have constant coefficients, so a method of undetermined coefficients does not apply. So this equation does not have constant coefficients. Which means that the method of undetermined coefficients does not apply. Thus, we are forced to use reduction of order to solve this problem, at least with the skills we know so far. So we must use reduction of order. So the very first thing we need for doing reduction of order is we need to find a homogeneous solution, and specifically a non-trivial homogeneous solution. And we were told that we could use, so we were given y1 equals e to the 2x. For most reduction of order problems, you will be given y1. Let me update my screen. Again, we need to find a non-trivial homogeneous solution. In this problem, we are given such a solution, and that will be the case for most reduction of order problems, unless we are in the constant coefficient case. So we have our homogeneous solution. Next up, we are going to assume that y equals u times y1 is a solution to the non-homogeneous equation. So it is a solution to x plus 1 times y double prime minus y prime plus negative 4x minus 2 times y equals x plus 1 squared times e to the negative 3x. So that means we need to find the derivatives of y and plug it in. So in this case, y1 was e to the 2x. So we have y is equal to u times e to the 2x. That means that y prime is u prime e to the 2x plus 2u e to the 2x. For y double prime, we would have u double prime e to the 2x plus 2u prime e to the 2x. That's product rule on the first term. Product rule on the second term, we would have a 2u prime e to the 2x plus 4u e to the 2x. And simplifying, we get u double prime e to the 2x plus 4u prime e to the 2x plus 4u e to the 2x. Now we're going to go and plug this in. So plugging into the equation. This becomes rather lengthy quickly. We have x plus 1 times y double prime. So x plus 1 times u double prime e to the 2x plus 4u prime e to the 2x plus 4u e to the 2x. Then we have minus y prime. So we will have minus u prime e to the 2x plus 2u e to the 2x. Then we have plus negative 4 minus 2 times y. So we have plus negative 4 minus 2, sorry, negative 4x minus 2 times u e to the 2x. And this whole thing added together should equal x plus 1 squared times e to the negative 3x. So rearranging this, we get something in front of u double prime, something in front of u prime, and something in front of u. So let's first look at just the u double prime term. So we have x plus 1 times u double prime e to the 2x. So we would get x plus 1 times e to the 2x times u double prime. Then if we look at our u prime, we have an x plus 1 times a positive 4u prime e to the 2x. And we have a negative 1 times a u prime e to the 2x. So we would have plus a 4 times x plus 1 and then minus 1 times e to the 2x times u prime. Then if we do our u terms, we have an x plus 1 times a positive 4u e to the 2x. We have a minus times positive 2u e to the 2x. And we have a plus negative 4x minus 2 times u e to the 2x. So from here we have plus, we have x 4 times x plus 1. Then we have a minus 2 and plus negative 4x minus 2. All of this times e to the 2x u, and it should equal x plus 1 squared times e to the negative 3x. So again, this u double prime was what I underlined in purple. The u prime was what I underlined or with a wavy blue line. And then the u term came from my zigzag green underline. Let me update my screen. We have our corresponding components, which all should add together to x plus 1 squared times e to the negative 3x. So from here, because e to the 2x was a solution, that component in front of the u should go to 0. So we would have 4 times x minus 4x gives us 0x, and then 4 times 1 is 4, minus 2 does give us 0. So this first component, as we hoped, does go to 0. So we are left with a simplified equation, x plus 1 times e to the 2x u double prime plus 4 times x gives us 4x. Then we have 4 times 1 minus 1 becomes plus 3 times e to the 2x u prime. I'm actually going to leave that in the original form. 4 times parentheses x plus 1, all of that minus 1, times e to the 2x u prime. And this is equal to that right-hand side, x plus 1 squared times e to the negative 3x. The reason I left that right-hand or the term coefficient in front of the u prime as I did is if we now divide through by the x plus 1 e to the 2x, we wind up with u double prime plus we would have 4 times x plus 1 in parentheses, and then minus 1 divided by x plus 1. Then we would have e to the 2x over e to the 2x, all times u prime. And this is equal to x plus 1 squared over x plus 1 times e to the negative 3x over e to the 2x. I left the coefficient in front of u prime as I did because this winds up simplifying to u prime plus, we have a 4 minus 1 over x plus 1 times u prime. And then on the right-hand side, we would have x plus 1 times e to the negative 5x. I did the simplification on the left-hand side so that when we go to find our homogeneous solution for our linear equation, we have something that's already, the long division is already performed, and we have something easily integrable. So from here, our next step is to set v equal to u prime and solve for v. So we are looking at the equation v prime plus 4 minus 1 over x plus 1 times v is equal to x plus 1 times e to the negative 5x. So the first thing we want to do is we are going to find the homogeneous solution first. So for our homogeneous solution, we have v1 is equal to e to the negative integral of 4 minus 1 over x plus 1 dx. This gives us that v1 is equal to e to the negative 4x plus natural log absolute value of x plus 1 plus c. We can write this as e to the negative 4x times e to the natural log absolute value of x plus 1 times e to the c. We can rewrite this as a capital C, e to the negative 4x times x plus 1. And we will go ahead and pick v1 equal to x plus 1 times e to the negative 4x. Next up, we are going to do variation of parameters. So we will assume v is equal to w times v1. Then we wind up with the equation w prime is equal to the right-hand side of our linear equation. So x plus 1 times e to the negative 5x. Divided by v1. So we are looking at w prime is x plus 1 times e to the negative 5x divided by x plus 1 e to the negative 4x. And we wind up getting that w prime simplifies down to e to the negative x. From here, we therefore get that w is the integral of e to the negative x dx, or w is negative e to the negative x plus a constant c1. Then we had v, which was w times v1. v1 was x plus 1 times e to the negative 4x. So we are looking at x plus 1 times e to the negative 4x, all times negative e to the negative x plus c1. This becomes v is equal to a negative x plus 1 times e to the negative 5x plus C1 times x plus 1 times e to the negative 4x. Next step, we are going to solve for u. So we will use the fact that u prime equals v to find u, or to solve for u. So we wind up with u prime is equal to negative x plus 1 times e to the negative 5x plus c1 times x plus 1 times e to the negative 4x. And therefore u should be the integral of negative x plus 1 times e to the negative 5x plus c1 times x plus 1 times e to the negative 4x dx. I'm going to do each of these using integration by parts. So let's start off with our negative x plus 1 times e to the negative 5x. So we'll take our u and dv as negative times x plus 1 and e to the negative 5x. So we go to negative 1 and then 0, differentiating on the left. Integrating on the right, we would go to negative 1/5 e to the negative 5x, and then 1/25 e to the negative 5x. We add or do positive product on the first and then negative product on the second diagonal. So we get that the integral of negative x plus 1 e to the negative 5x dx is equal to a 1/5 times x plus 1 times e to the negative 5x plus 1/25 e to the negative 5x. And then if we combine like terms, this becomes 1/5 x plus 6/25 times e to the negative 5x. Then if we work with a second integral, we are looking at a c1 times x plus 1 times e to the negative 4x. So if we take our u to be c1 times x plus 1 and our dv to be e to the negative 4x, differentiating down the left, we wind up with c1 followed by 0. Integrating down the right, we have negative 1/4 e to the negative 4x followed by 1/16 e to the negative 4x. We do the negative product on the first diagonal, positive product on the second diagonal. We are looking at the integral of c1 times x plus 1 times e to the negative 4x dx. This is equal to c1 times x plus 1 times positive 1/4 times c1 times x plus 1 times e to the negative 4x. And then we have a plus 1/16 times c1 times e to the negative 4x. Combining like terms, we have c1 times 1/4 x plus 5/16 I don't know why I had to minus and then plus. We do the positive product first, negative product second. So this should have been a negative 1/4 and then a minus 1/16. We have a negative 1/4 x and then a minus 5/16. And then times e to the negative 4x. Now, let me pause and update my screen. I'm just going to box the things I just fixed. So we should have had a positive product on the first diagonal, a negative product on the second diagonal. So this became a negative 1/4 and a minus 1/16. So we had a C1 times negative and minus 5/16. So we can play a little trick here because C1 is just an arbitrary constant. We can pick a new C1. So now let's set capital C1 to be, let's do negative 1/16 times lowercase c1. Then this becomes a capital C1 times a positive 4x minus 5. Essentially, we factored out a negative 1/16 and then times e to the negative 4x. So we can use this trick regularly. We can kind of absorb scalar multiples into our constant if you like. Our integral on the left, we didn't have that constant multiply or scalar multiple C1 or C2 up front, so there's nothing to absorb it into. We can't absorb the 1/25. All right, so from here, we therefore have that u should be equal to that first component, 1/5 x plus 6/25 times e to the negative 5x plus our second component, C1 times 4x minus 5 times e to the negative 4x. So our final step 5 is find y equaling u times y1. So just a reminder, our y1 is way, way, way back here. These are long problems. Our y1 was e to the 2x. So we are looking at y is equal to e to the 2x. Oh, I apologize. I forgot my final plus c2. So u, we just took another integral. We should introduce one more constant. So now we have y is equal to e to the 2x times 1/5 x plus 6/25 times e to the negative 5x plus c1 times 4x minus 5 times e to the negative 4x plus c2. Multiplying this in, we get that y is equal to 1/5 x plus 6/25 times e to the negative 3x. Then we have a plus c1 times 4x minus 5 e to the negative 2x plus c2 e to the 2x. So in running reduction of order, we have found our particular solution, yp, and then the plus c1, 4x minus 5 e to the new 2x plus c2 e to the 2x is our homogeneous general solution. So as you saw in a couple places here, it's very easy to forget to do a plus C or to mess up your signs, and that can mess up the entire problem. So these problems, you have to be pretty meticulous as you work your way through. Make sure your algebra is correct. When it comes to doing these problems in grading, minor arithmetic error isn't going to be a huge deal. I'm looking more for the process, but a minor arithmetic error can drastically change what integration you're looking at. And so you do want to be careful so that you wind up with hopefully a simpler integration problem.